I really need to get this work done, but I need to eat this. Oops. Hi everyone! So today I'm going to talk about something really interesting, and of course it's gonna involve chocolate, but from a science and environmental angle. So the journal that I read title is Cocoa Butter Substitute from Palm Meat Fraction, Palm Kernel Oil, Palm Stearin for Confectionery Fillings. It was published in the Journal of American Alchemist Society in 2017. So what is it so important about this study? We all love chocolate, right? But the key ingredient to chocolate is cocoa butter. And cocoa butter is really expensive, not easy to get, and can be linked to environmental issues like deforestation due to cocoa farming. Okay, one question: how does this process will help us to reduce the environmental issue? So, the main objective of this study was to create a cocoa butter substitute that is more cheaper, more sustainable, using 3 parts of palm oil. The first one is palm meat fraction, palm kernel oil, and palm stearin. These are basically different types of fats taken from palm oil process. The researcher wanted the final fat blend to have similar properties to cocoa butter, like the way it melts, its texture, and the crystal structure, so it could be used in the chocolates and filling without losing its quality.
So this study analyzed the fatty acid methyl ester (FAME) and also triacylglycerol (TAGs), where it profiles of the blend using gas chromatography (GC) and high performance liquid chromatography (HPLC), where GC is used to separate and quantify the individual of fatty acids after they have been converted to FAMEs, and HPLC is used to analyze the intake of TAG molecules.
So first, for the RBD palm stearin, it is known to have a high melting point solid fat with low linoleic acid content. It is making stable against oxidation. Blending these fractions allows the fatty acid and TAG composition to resemble the cocoa butter more closely. While for the RBD palm kernel oil, it contains high amounts of short-chain fatty acids, which is like lauric and myristic acids. And lastly, for the palm meat fractions, is rich in palmitic and oleic acid and has a triacylglycerol profile that's similar to cocoa butter. So for the production and refining, there's raw materials, which is palm meat fraction, RBD palm kernel oil, and RBD palm stearin are refined, bleached, and deodorized palm oil fractions, which are industrially processed to remove impurities and odors. These processes are essential in producing fats that are suitable for food application like confectionery. This study uses these refined fractions as base materials for blending without using the hydrogenation method, which is traditionally used but produce trans fat.
It is needed to avoid producing trans fat in foods since it will increase the LDL, which is bad cholesterol, and decreasing the HDL, that is good cholesterol. Besides, it also increases the risk of heart disease, stroke, type 2 diabetes, and along with any diseases that associate with inflammation and insulin resistance.
So instead of hydrogenation, which introduced the trans fat, this study employs the blending of different palm oil fractions to modify their properties. This approach is focused on physical blending to achieve the desired melting and crystallization behavior without the chemical modification. These ternary blends are melted at 80 degrees Celsius to erase the crystal memory and then to temper for analysis.
Analytical methods were used to evaluate the physical and chemical properties of fat blends. We started by blending 3 types of palm oil fractions, PMF, RBD PKO, and RBD PS, being poured into a container. They will melt at 80 degrees Celsius for 30 minutes, then cool to 25 degrees Celsius to erase any crystal memory. To understand what is inside the blend of cocoa butter, we analyze fatty acids and triglycerol using GC and HPLC. We also examine how the fat crystallizes using X-ray diffraction and polarized light microscopy. We want small, stable crystals, ideal for smooth and creamy texture. With differential scanning calorimetry, we study melting points. The ideal blend melts at 18.5 degrees Celsius and 36 degrees Celsius, right around our body temperature. Lastly, we mapped how the three fats mix using iso-solid phase diagram. This helps us find the blend that behaves best both in texture and stability.
Hi everyone, in this section, I will explain the results and discussion of the study on making a cocoa butter substitute, or CBS, from palm oil blends. Let's see how the researchers created a blend that works just like real cocoa butter without the high cost. The best combination they found was a mix of 14.9% palm meat fraction, 59.6% palm kernel oil, and 25.5% palm stearin. This mix showed a fatty acid and TAG profile very close to natural cocoa butter. It also had a good crystal structure, which is important for the smoothness and texture in chocolate fillings. They also check how the blend melts using DSC, which is differential scanning calorimetry, and found two melting points, one at 18.5 degrees Celsius and another at 37 degrees Celsius. So why is this important? Because we want fillings that are firm at room temperature but melt in our mouths like real chocolate. So this melting profile is just right for that. Next, they look at the solid fat content, or SFC. This tells us how solid or soft the fat is at different temperature. The blend stayed solid at room temperature but become liquid near body temperature. That's exactly what we want for smooth texture, no waxy feel, and easy bite through in confectionery. They also drew something called an iso-solid phase diagram. This helped them see if the fats mix well together. Turns out the blend showed monotactic behavior, which means the fats were highly compatible. This is very important for keeping the product stable and uniform during storage and use. Then, using X-ray diffraction and microscopy, they studied the crystal structure. The fat formed in beta crystals. That's great news because beta crystals give a fine texture, good gloss, and pleasant mouthfeel, while avoiding the grainy or gritty chocolate texture. So, in short, the researchers successfully created a palm-based fat blend that can mimic cocoa butter's behavior without using hydrogenation or trans fats. It's a cheaper, healthier, and sustainable choice for confectionery products.
Now, here's the environmentally friendly part that I found really cool. All the fat that they use, PMF, palm stearin, and palm kernel oil, are actually from byproduct. Normally, these might be underused or thrown away, but this study gives them a new purpose. So, instead of wasting these extra palm oil parts, the researcher wants to make something more valuable, which is a chocolate fat that works well and also helps to reduce waste. That's a perfect example of circular economy, which is reusing material instead of creating more waste. So, in short, this study shows us that we can make chocolate that is not just delicious but also smarter and greener. It's cheaper, it uses materials that might go to waste, and it supports more sustainable production. And honestly, if we can help the environment while still eating chocolate, that sounds like a sweet win to me. So that's all from us. Thank you.